We're going to take a few minutes here and make sure that what's in your notes is correct. So for conditional convergence, if the positive series, check your notes, make sure this is what you have written, diverges, and the alternating series converges. Remember, our alternating series has to have convergence anyway to be able to talk about absolute or conditional. Okay, so if the positive series diverges while the alternating series converges, then the alternating series converges conditionally. Make sure that's what's in your notes. I hate that I grabbed something off the internet without checking it before I got deep into a video. But that's what needs to be in your notes. That is conditional convergence. Now, if they both converge, that's absolute convergence. So that's all we're testing. In practice, it's a lot easier than it is in words. So let's work a couple of examples. Is the given series convergent or divergent? If it is convergent, is it absolutely convergent or conditionally convergent? Well, here is an alternating series. Is it okay that not every single term alternates back and forth, positive and negative? Yes, it is. As long as we have some negatives thrown in there and not every term is positive, we have an alternating series. So I want to rewrite the alternating series where the alternating term, this is n times n plus 1 over 2, is out front, and the positive portion of the alternating series is written over there by itself. And now you know why I do that, because if they ask me about an alternating series convergence, they could ask me about what type of convergence. So I need to identify the positive series as well as the alternating series. So this is an alternating series. As a matter of fact, it's one we've already determined does converge, but we'll run the limit just to verify. As n gets large, the denominator gets huge. 1 over huge is tiny. This series converges by the alternating series test. See how important it is to identify what test you're running. Now I'll pick up another color, and since we've determined it is convergent, let's see what type of convergence we have. Well, the type of convergence depends on what that series does. Does the sum converge or diverge for that series? Well, we're back to positive series. We're back to all those tests that we know. And so we can pick any test we want to. This is one case where I would hope you would recognize that it could be written in that form. This is a geometric series. All we have to do is identify it as a geometric series, identify that its common ratio is less than 1, and then we can state that this series converges. So, we're not done yet. So, hence, or thus, the alternating series that they originally gave us converges, and it converges absolutely. How do I know it converges absolutely? Because the alternating series converges and the positive series converges. That's what I need for absolute convergence. All right, one more example, and then I think we'll be ready to do some homework problems. So is the given series convergent or divergent? If it is convergent, is it absolutely convergent or conditionally convergent? Well, let's hope we recognize the alternating harmonic series. Remember, in the last video, if we recognize it as the alternating harmonic series, we get to say we know that series converges just by definition. So now, since it is convergent, we can talk about what type of convergence. Let's talk about its positive counterpart. Well, the positive counterpart is the harmonic series. By definition, we know this series diverges. So, the alternating harmonic series is conditionally convergent, or it converges conditionally, or has conditional convergence. How do I know that? Because the alternating converges, which means I can qualify it, is absolute or conditional, but the positive diverges, which is the definition of conditional convergence. All right, so I think that's enough information. Come to class next time. We'll work some homework problems. Alternating series couldn't be easier. And as it turns out, alternating series show up on the AP exam a lot. So let's work some homework problems and make sure we're ready for that.